Hello everyone, welcome to the online session of Unit 3 called Software Architecture and Planning a Software Project of the course called Software Engineering, having the course code 15CS51T for the program Diploma in Computer Science and Engineering from the Department of Collegiate and Technical Education, Government of Karnataka. The agenda of this session is to discuss about the understanding of risk management in software development, types of risks in software project management, risk management plan, elements of risk management plan, a practical risk management planning approach, and an example for the same. Before we start the current session, let's have a brief recap of the previous session. Software development is an activity that uses a variety of technological advancements and requires high levels of knowledge. Because of these and other factors, every software development project contains elements of uncertainty. This is known as project risk. The success of a project development depends quite heavily on the amount of risk that corresponds to each project activity. It's not enough to merely be aware of the risks. To achieve a successful outcome, it is quite essential to identify, assess, prioritize and manage all of the major risks. Because risks are painfully real and quite prevalent on all software projects, it's critically necessary that stakeholders work hard to identify, understand and mitigate any risks that might threaten the success of a project. For projects that have time and cost constraints, experience shows most clearly that successful software development efforts are those in which risk mitigation is a central management activity. Now let's try to understand what is risk in software engineering. Very simply, a risk is a potential problem. It's an activity or an event that may compromise the success of a software development project. Risk is the possibility of suffering loss, and total risk exposure to a specific project will account for both the probability and the size of the potential loss. Guesswork and crisis management are never effective. Identifying and aggregating risks is the only predictive method for capturing the probability that a software development project will experience unplanned or inadmissible events like terminations, discontinuities, schedule delays, cost underestimation, and overrun of project resources. What is risk management in software engineering? Risk management means risk containment and mitigation. Risk management ensures that the impact is minimal. Here, first you have to identify risks and plan accordingly. Then, be ready to act when a risk arises, drawing upon the experience and knowledge of the entire team to minimize the impact of the risk on the project. Risk management includes the tasks of identifying risks and their triggers, classifying and prioritizing all risks, crafting a plan that links each risk to a mitigation, monitoring for risk triggers during the project, and executing risk mitigation steps. That is, implement the mitigating action if any risk materializes and then communicate the risk status throughout the project. Five types of risk in software project management. For most software development projects, we can define five main risk impact areas, which are new unproven technologies being used, user and functional requirements, application and system architecture, performance, organizational. New and unproven technologies. The majority of software projects entail the use of new technologies. Ever-changing tools, techniques, protocols, standards, and development systems increase the probability that technology risks will arise in virtually any substantial software engineering effort. Training and knowledge are of critical importance, and the improper use of new technology most often leads directly to project failure. User and functional requirements. Software requirements capture all user needs with respect to the software system features, functions, and quality of service. Too often, the process of requirements definition is lengthy, tedious, and complex. Moreover, requirements usually change with discovery, prototyping, and integration activities. Change in elemental requirements will likely propagate throughout the entire project, and modifications to user requirements might not translate to functional requirements. These disruptions often lead to one or more critical failures of a poorly planned software development project. Now let's understand the application and system architecture area. Taking the wrong direction with a platform, component, or architecture can have disastrous consequences. As with the technological risks, it is vital that the team includes experts who understand the architecture and have the capability to make sound design choices. Performance area. It's important to ensure that any risk management plan encompasses user and partner expectations on performance. Consideration must be given to benchmarks and threshold testing throughout the project to ensure that the work products are moving in the right direction. Next risk area is organizational. Organizational problems may have adverse effects on project outcomes. Project management must plan for efficient execution of the project and find a balance between the needs of the development team and the expectations of the customers. Of course, adequate staffing includes choosing team members with skill sets that are a good match with the project. Risk management plan. After cataloging all of the risks according to type, the software development project manager should craft a risk management plan. As part of a larger, comprehensive project plan, the risk management plan outlines the response that will be taken for each risk if it materializes. Monitoring and mitigating the risk management plan. To be effective, software risk monitoring has to be integral with most project activities. Essentially, this means frequent checking during project meetings and critical events. Monitoring includes publish project status reports and include risk management issues. Revise risk plans according to any major changes in project schedule. Review and reprioritize risks, eliminating those with the lowest probability. Brainstorm on potentially new risks after changes to project schedule or scope when a risk occurs. The corresponding mitigation response should be taken from the risk management plan. Mitigating options include accept, acknowledge that a risk is impacting the project. Make an explicit decision to accept the risk without any changes to the project. Project management approval is mandatory here. Avoid, adjust project scope, schedule, or constraints to minimize the effects of the risk. Control, take action to minimize the impact or reduce the intensification of the risk. Transfer, implement an organizational shift in accountability, responsibility, or authority to other stakeholders that will accept the risk. Continue monitoring, often suitable for low impact risks. Monitor the project environment for potentially increasing impact of the risk. Communicate. Throughout the project, it's vital to ensure effective communication among all the stakeholders. Now let us understand different elements of risk management plan. These are typically a handful of elements that make up a risk management plan, and they are outlined below. First, identify risks. Risk identification occurs at the beginning of the project as well as throughout the project. While many risks are considered known risks, others might require additional research to discover. To identify risks, create a risk identification checklist that is specific to your project type. You can do this by interviewing all stakeholders and industry experts. Additionally, create a risk repository that you can share with everyone you interviewed for a centralized location of all known risks revealed during the identification phase. This can be conveniently done on an online project management software. Many risks can be divided up into categories like technical or organizational and listed out by specific subcategories like technology, interfaces, performance, logistics, budget, etc. Second element is map out impact versus likelihood. Here, you will review the qualitative and quantitative impact of the risk, like the likelihood of the risk occurring versus the impact it would have on your project, and map that out into a matrix or spreadsheet. First, you will do this by assigning the risk likelihood a score from low probability to high probability. Then you will map out your risk impact from low to medium to high and assign each a score. This will give you an idea of how likely the risk is to impact the success of the project, as well as how urgent the response will need to be. To make it efficient for all team members and stakeholders to understand the matrix, assign an overall risk score or rank by multiplying your impact level score with your risk probability score. You can get started with your free risk assessment template. Third element is planning your risk response. Planning your risk response usually includes three main concepts: eliminating your risk and lowering both the impact of the risk on the project as well as the risk occurrence. Doing this usually comes with a price at the expense of your time or your budget. So you want to have your time, money and scope explicitly mapped out prior to creating your risk management plan. Fourth element is assigning an owner to the risk. Additionally, you will also want to assign a risk owner to each risk. While the default is usually the project manager, you may want it to be specific. When you create your matrix, list out the owner of each risk. That way, no one is confused as to who will need to implement the response once the risk occurs, and the owner can take immediate action. Be sure to record what the exact response is and have it approved by all stakeholders before implementation. That way, you can have a record of the issue and the resolution to review once the entire project is finalized. Fifth element is to understand your triggers. This can happen with or without a risk already having impacted your project, especially during project milestones as a means of reviewing project progress. If they have considered reclassifying those existing risks. Even if those triggers haven't been met, it's best to come up with a backup plan as the project progresses. Maybe the conditions for a certain risk won't exist after a certain point has been reached in the project. The sixth element is to make a backup plan. Consider your risk impact and probability matrix a living document. Your risk can change in classification at any point in time during your project, and because of that, it's important you come up with a contingency plan as part of your process. Contingency planning includes discovering new risks during project milestones and re-evaluating existing risks to see if any conditions for those risks have been met. Any reclassification of a risk means adjusting your contingency plan just a little bit. The seventh element is to measure your risk threshold. Measuring your risk threshold is all about discovering which risk is too high, and consulting with your stakeholders to consider whether or not it's worth it to continue the project. Worth it whether in time, money or scope. Now let us try to understand a practical risk management planning approach which will be commonly used in many of the organizations. A simple practical approach used in many organizations for doing risk planning is to simply categorize risks and the impacts in a few levels and then use it for prioritization. In this approach, the probability of a risk occurring is categorized as low, medium or high. The risk impact can also be classified as low, medium and high. With these ratings, the following simple method for risk prioritization can be specified. 1. Rate the probability of each risk happening as low, medium or high. 2. Assess the impact of each risk on the project as low, medium or high. 3. Based on the probability and effects of risks on the project, rank the risks. For example, a high probability, high impact item will have higher rank than a risk item with a medium probability and high impact. In case of a conflict, judgment can be used to resolve. And 4. Select the top few risk items for mitigation and tracking. In the table given here is an example for the approach explained here. In this example, various ratings and the risk mitigation steps are shown. As we can see here, the risk management plan can be very brief and focused. Risk management planning at milestones can be redone for monitoring the risk, giving more attention to the risks listed in the project plan. During risk monitoring at milestones, depending upon the current situation and the impact of mitigation steps taken earlier, reprioritization may occur and mitigation plans for the remainder of the project may change. The first risk identified here is failure to meet the high performance, which has the probability as high, impact also as high, and the exposure of the risk is high as well. So the mitigation plan is to study white papers and guidelines on performance, to train team members on performance tuning, to update review checklist to look for performance pitfalls, to test application for performance during system testing. Risk number 2 identified here is lack of people with right skills, which has the probability of occurrence as medium, impact as medium and exposure as medium. The mitigation plan for this risk is to train the resources, to review the prototype with customer, and to develop the coding practices. Risk number 3 is the complexity of application, which has the probability of occurrence as medium, impact as medium, and exposure as medium. The mitigation plan for this risk is to ensure ongoing knowledge transfer, to deploy persons with prior experience with the domain. Risk number 4 is manpower attrition, which has the probability of occurrence as medium, impact as medium, exposure as medium. And the mitigation plan for this risk is to train a core group of 4 people, to rotate assignments among people, and to identify backups for key roles. Risk number 5 is unclear requirements, which has the probability as medium, impact as medium, and exposure as medium. The mitigation plan for this risk is to review a prototype and to conduct a mid-stage review. Now let us try to answer a few of the multiple choice questions. First one is, risks are those events, number 1, which may occur, 2, which may not occur, 3, they can have negative impact on the project. Which of the statements given above are true? Option A, 3 only. Option B, 1 and 2 only. Option C, all of the above. Option D, none of the above. Do you know the answer for this question? Yes, the answer for this question is option C. That is all of the above. That means risks are those events which may or may not occur, but when they occur, they have negative impact on the project. Let's try to answer the next question. The expected loss from a risk is a combination of 1. The materialization of the risk, 2. Probability of the risk, 3. The total possible loss due to materialization of the risk. Which of the statements given above is or are correct? Option A, 1 and 2 only. Option B, 2 and 3 only. Option C, 1 and 3 only. Option D, none of the above. What is the answer for this question? Yes, it is option B. The correct answer is option B, 2 and 3 only. That is, the expected loss from a risk is a combination of probability of the risk and the total possible loss that occurs due to the materialization of the risk. So the next question is, A simple approach of doing risk planning is to 1. Categorize the risks in a few levels. 2. Categorize the impacts in a few levels. 3. Prioritize risks based on levels. Which of the statements given above is or are correct? Option A, 1 and 3 only. Option B, 1 and 2 only. Option C, 2 and 3 only. Option D, all of the above. Do you know the correct answer for this question? Yes, the correct answer for this question is option D, all of the above. That is, a simple approach of doing risk planning is to categorize the risk in a few levels, categorize the impacts in a few levels, and then prioritize the risk based on these levels. So the next question is, probability of the risk occurrence may be rated as low, medium or high. The above statement is true or false. What is the answer? Yes, the answer is true. Probability of the risk occurrence may be rated as low, medium or high. Impact of the risk on the project may be assessed as low, medium or high. What is the correct answer here? Option A false or option B true? Yes, the correct answer here is true, because the impact of the risk on the project can be assessed as low, medium or high. So the next question is, in a practical risk management planning approach, all of the risk items are selected for mitigation and tracking. Option A is false, option B is true. So what is the correct answer for this question? Yes, it is option A. The above statement is false, because in a practical risk management planning approach, only a top few risk items are selected for mitigation and tracking, not all of them. So the next question is, mitigation plan for tackling the risk of unclear requirements may include 1. Developing coding practices, 2. Reviewing a prototype, 3. Conducting a mid-stage review. Which of the statements given above is or are true? Option A, 1 and 3 only. Option B, 1 and 2 only. Option C, 2 and 3 only. Option D, all of the above. What is the correct answer for this question? Yes, it is option C, 2 and 3 only. That is, a mitigation plan for tackling the risk of unclear requirements may include reviewing a prototype as well as conducting a mid-stage review. Mitigation plan for tackling the risk of manpower attrition may include 1. Rotating assignments among people, reviewing a prototype with the customer, 3. Identifying backups for key roles. Which of the statements given above is or are correct? Option A, 1 and 3 only. Option B, 1 and 2 only. Option C, 2 and 3 only. Option D, 1 and 3 only. Do you know the correct answer for this? Yes, it is option D. That is 1 and 3 only. Mitigation plan for tackling the risk of manpower attrition may include rotating assignments among people as well as identifying backups for key roles. So the next question is, deploying persons with prior experience with the problem domain will be helpful in handling the complex application. Your options for this are option A true, option B false. So which one is the correct answer for this? Yes, option A is the correct answer. That is, deploying persons with prior experience with the problem domain will be definitely of some help in handling the complex application. So the next question is, lack of people with right skills in a project execution may be handled by 1. Training resources, 2. Developing coding practices, 3. Reviewing prototype with the customer. Which of the statements given above is or are correct? Option A, 1 and 3 only. Option B, 1 and 2 only. Option C, 2 and 3 only. Option D, all of the above. So what is the correct answer here? Yes, the correct answer here is option D, all of the above. That is, lack of people with the right skills in a project execution may be handled by training resources, developing coding practices, as well as reviewing prototype with the customer. So these are the answers for the multiple choice questions that have been asked here. Now let's recall a brief summary of what we have discussed in this session. Most of the software projects are risky because of the range of serious potential problems called risks that can arise. If risks occur, they can have a negative impact on the project. Therefore, a proper risk management is required to achieve project goals under the presence of risks. Risk management is an extensive discipline, and only an overview of risk management is given here. Always be forward thinking about risk management. Otherwise, the project team will be driven from one crisis to the next. Use checklists and compare with similar previous projects. Prioritize risks, ranking each according to the severity of exposure. Develop a top 10 or top 20 risk list for your project. Rigorously watch for surfacing risks by meeting with key stakeholders. As practicable, split larger risks into smaller, easily recognizable and readily manageable risks. And then plan the activities such that if the high priority risks occur, their effect is minimized. The source of reference. The source of reference used here for the session is a textbook called Software Engineering, A Precise Approach, written by Dr. Pankaj Jalote, and A Concise Introduction to Software Engineering by Pankaj Jalote, and a few of the websites whose URLs are specified here. Thank you everyone.